All right.
Yeah,
What's up? Hey, I'm Austin Griffith. Happy Bowtie Friday. I'm here with the Ethernaut, and we are going to dive into his stack and how he uses it, and kind of like this really cool way you can take HartHat and kind of fork it to look at mainnet. So I'll let you kick it off. Basically, we're kind of just going to explain what the heck credit delegation is on Aave, right? It's kind of an intricate thing itself, but then we'll get in and it'll be more generalized of how we can use HardHat to interact with it and how we can test it kind of locally before we go live with it. So, hey man, how's it going? Thanks for being on here. Let's dive into this.
Hey, what's up? Thank you for inviting me. So yeah, we can go with this little repo I made that I kind of used yesterday for a real credit delegation, something that the Aave UI doesn't support yet, but it was really easy, right? So let's go over it, should we?
Yes, please. Heck yeah.
So here's a little diagram I made to understand what's going on, right? So let's go over it. So you got a lender and a borrower, and basically the lender would go to Aave and just deposit collateral, whatever collateral the lender wants, and that'll be step one, right? And then at that point, you need to go off course, let's say, to.
You mean outside of the UI? Uh-oh, I think I might have lost you.
I think the docs are here. Yeah, it has.
Sorry, I think I lost you for a second.
Okay. Oh yeah, I might be on a slow connection.
I think we're good. I think we're good. So basically, you were talking about going off the course and how we need to get kind of get reserve token addresses. And I think what you meant by go off the course is outside of the UI, basically outside of the Aave UI. Yeah.
So you need to interact with contracts directly. If you go to the documentation for Aave v2, you can see deployed contracts, and then you have like lending pool and protocol data provider. I found those to be like central contracts, you know. And lending pool is mostly what you use in the UI. Like you have borrow, deposit, repay, withdraw, like the main stuff, right? And then another important one is the data provider. Yeah, this one. This guy basically. You can ask it, okay, what's the A token address for a particular underlying asset like DAI, you know? Or also what's the, I think slightly less known, I'm by no means an Aave expert. I just found out what I needed to know. And I identified like these two like central contracts, the pool, the lending pool right here, and the data provider. The lending pool is what you use, the deposit, withdraw, borrow, and all that. And then the data provider will give it an asset like the address of DAI, and it will give you an A token, and it will also give you debt token addresses. So it's
kind of like a phone book for you for like where all the contracts are, some kind of on-chain resource you can query for like, here's where this token is. And I even see like reserves. Here's how much of this token.
Yeah.
Cool.
The documentation is excellent, like of the best I've seen. And everything should be here. So again, in my little repo, you're going to have links to that, etc. So going back to the diagram, step one, you can do it on the UI, like app.aave.com version 2, right? You deposit collateral. Step two, you need to go to the data provider on Etherscan, and you need to ask it, okay, what's give me the debt token of, let's say, DAI, right? So, and that gives you an address back. Basically, it's an ERC20 token that has additional functions. One of them is approved delegation. So on step 2, the lender gets that contract. Step 3 calls a proof delegation with 2 parameters. One, who, and the second parameter is how much, right?
So just like with
And
an ERC20 where you can approve someone to transfer it, this is a token you've gotten back for providing collateral, and you're going to approve someone to use that collateral to take out a loan. Is that right? This is
correct.
Cool. Neat.
And then, it's like super simple in the end. And then that allows me to go into the UI and just borrow. But okay, now that I remember, like the UI didn't, it didn't allow me to borrow because I had no deposits. But I think that's just a UI thing. I bet if you deposit like 1 cent, it would show you that you can borrow like the I don't know, $10,000 that you got approved for.
And we saw Stanley on Twitter tweet back at you that you were releasing it even before he had released it, right? It's probably because stuff like that, like they hadn't gotten the UI caught up with the new smart contract.
Yeah, I guess it's on the roadmap. I have no idea, but it should be simple enough. So in the end, I ended up going to lending pool and just calling borrow, right? So yeah, then what this little repo is, like, this is not just a README, right? This repo, it has it can fork mainnet and simulate the whole flow, right?
So we've got HartHat, and HartHat can bring up a node. Maybe we should talk about that first. Like how do we bring up the HartHat node? How does the HartHat node fork from mainnet? Like maybe that's the first, because what we want to do here is kind of simulate mainnet and fake this delegation to make sure it all is going to work the way we think it is, right? So the first thing we need is our own local node, but we need that forked from mainnet. And that's you're going to do that with HartHat, right?
Yeah, before that, I just want to see it working and then have that.
Okay. Run it to work and then work through it. I got it. I'm with you.
Yeah. Okay. So this is the main file of the repo, basically a test that you can tell it how much you want to deposit, how much you want to borrow, right? And it's gonna fork mainnet and run a bunch of transactions against the fork, and just fail or succeed. So here it's going to deposit 120 ETH and borrow 35K DAI, and we're just going to do npm test. It's forking mainnet, and then it's going to take a while because it's like real-ish transactions.
So we've forked mainnet, we've gone to the lending pool and the data provider contracts, we've queried those, we've got our rates and our A contracts, and now you're actually putting the 120 WETH in and trying to get
now
back.
It's checking liquidity.
Oh, you're delegating.
It's making sure that the user has 120, and that's this little one here actually corresponds to the one in the diagram.
Oh, so the steps.
It's
nice.
It's depositing.
Okay.
So that's takes a.
And what account is it using to do this? Like, are these like God mode accounts on mainnet, or how have you set up the account and funded it?
There's this little JSON file I'm using, which has local users that are automatically generated by the local chain. Then Aave official addresses, then official token addresses, and then I looked these up on Etherscan. They're like holders. Like
you just found like a random account that has a bunch of it, and then you can take over that account since you're forking mainnet. So cool.
Right. And one of the features that HartHat has is that you can pawn any address. So you can simulate that you have the private key. So one of the steps of like this part here is when the lender has 120 ETH, it's basically gonna pawn the associated account and send that. In this case, it's just ETH. Well, it's actually wrapped ETH, right? It's gonna send that to the account you're using as your user. We can see that in the tests. But yeah, I guess the first part would be creating a new HartHat project than setting up a fork, right? So if you want, we can do that from scratch and use this as a like our cheat sheet.
Let's go for it.
I'm not gonna make it work. I'm just
Okay.
gonna show you like
Okay.
so that like there's no mystery to this. You just
Okay.
need to do this. So I guess npm init, right? Oh, I forgot the yes. Okay. Good. All right. Then
So we've got a new
npx,
npm package.
npm install HartHat, I guess. Right.
Yep.
This is like
Previously
I do this
diddler.
like 20 times a day.
Do you? That's
Yeah.
great. This is exactly what I wanted to see. I wanted to see like your day-to-day, like here's my day-to-day tooling and here's how like here's the mess I get myself stuck into and here's how the tools help me get out of that mess.
Yeah, probably if I were smart, I would like just have a template or something. So this created, just a package JSON, no modules, and now we can do npx HartHat, right? And it will ask you, okay, what do you want to do? I want to create a sample project. I always create a, oh, my bad. I chose the other one. So I think if I delete that, I can do it again. Yeah.
So it's just looking for that config file and it'll kind of create some scaffolding here for you. Very cool.
Yeah, it's awesome. It's very polished.
Oh yeah.
Okay, so now it's just installing a bunch of dependencies. The default ones, which I found to be awesome. I think it's Ethers and Waffle.
And there's a whole bunch of plugins on their website, right? Like HardHat deploy, and there's probably even like plugins for like Etherscan verification, things that builders find themselves needing. Go check out the plugins on the HardHat website.
Yeah. But often for simple things, like the default template is going to be more than enough.
A lot of times I just need like one or two little functions in there that kind of show me how to do it. And then I can kind of just like pattern match from there and kind of fill out what I want the script to do. But a lot of times having a little bit of scaffolding there helps a lot for me.
Yeah, for sure. Well, this creates a contract, a little contract, a script that you can do like just execute some interaction with your contracts from the CLI.
Get your balance, make some transfers. Yeah, cool.
A test and this like configuration file where you can tell you about networks and stuff. So I guess the next thing that you would like to do is like let's read the balance of dye. I mean the total supply of dye, right? How would you do that?
So we need to fork mainnet first, and then we want to kind of like pawn some account and go check that. That would be a cool kind of like little, if we can fork mainnet and then pawn one of those accounts and send some dye to like the 0 account of the HardHat node or something like that. Yeah,
let's do that. Okay.
Neat.
So first, what we need to, let's see. Let's configure this a little bit. I think you need to have a networks array, right? And you need to specify, let's do, for example, I'm going to use a cheat sheet, all right?
Of course, yeah. I always have lots of copy and paste available, and it's nice to have this stuff here. Yeah, there we go. HardHat forking.
Yeah, Sweet. That's it. So we're going to have a network called HardHat, and we're going to tell it to have forking, right? So I'm just gonna copy this over, and that's pretty much it. So right here, we're gonna need a URL. So
basically some RPC endpoint like in Fura or one of our own local nodes.
Yeah.
Cool.
Yeah, let me just get one of my own, like one I usually don't mind sharing.
Yeah, I can send you one also. Do you want, how about just like the default?
No,
you got one? Okay, cool. I can hook it up too, for sure. Okay. Yeah, I don't want to dox your good Infura key or anything like that.
Yeah, don't worry. It's just
okay.
I even push it to GitHub
Right.
sometimes.
Yep.
Like, I don't mind. All right, so here it is. That's it. Okay. So basically now we can do
Probably
I think
HardHat
it's
node or something like that.
NPX
Yeah.
HartHat node.
There we go.
And
Oh,
okay.
you have to tell
So
it. It's already on the default network, right? Or you may need to set the default network to HardHat.
No, yeah, that's for testing. Like,
Okay.
if you put it here, it's for testing. But
Okay.
if you want to run it on the CLI, you don't even need to.
Oh, I see.
You just
Okay.
do HartHat.
We're doing
test. And specify the network, and it will run. But if you wanted to start up a fork on one terminal and interact with it on another terminal, you would have to do this HartHat node fork and specify the provider
inline.
Right?
Got it. So we can fork inline, or we can fork over here in the config file.
Yeah. So let me just show you. Like, we're not going to see it in the foreground when we run the test. Yeah. I need to specify the network here. I think.
Wait, it still said network. I think it's using the one from your config file. Because it still said network in the error, right? Yeah.
Yeah. Okay, so maybe I don't even need to specify it like that.
Yeah, I think if you did HardHat or npx HardHat node, my suspicion is it's going to fork it from the mainnet over there on the left. Neat.
All right.
Okay. So now can we check like block number or something?
Yeah, you should be able to just go into the console. Like you can't interact here directly.
Okay.
If you do if you go straight into the console, you should be able to, like, I think it's npx HartHat console. And
yep,
I didn't specify the default network, but yeah, it looks like
we're connected.
It's
yep, there it is. Cool.
Yep. So you would have to connect to the provider and then query it. But
this is where I use ETH build. I would bring ETH build up and connect to my local node and then start calling block number and stuff on it. But we don't want to do that right now. that's a whole different side quest. Let's go for it though. So what we're assuming right now is we are connected to our own local node that is forked from mainnet, so we can kind of play around and do things on this network, but it's not going to cost us anything, and we can test that it's going to work. Very cool.
Yeah, you can do whatever you want. Flash loans. You can pawn a whale and send you all the balance. You can do whatever you want.
Let's grab that. Yeah, let's grab that balance from that guy. Can we do that? Can we grab the balance from your DAI whale and send some DAI to one of these addresses or something like that, just to show that it's working?
Yeah, for sure. Let's. I guess first we need to get an ERC20 interface, right?
Ooh, yeah.
So I'm going to change this to ERC20 or ERC20 or something. Okay, and it's gonna steal the int. I have it right here in another project. Right. Okay, so now we can say ethers. What's the connect with this contract at this address with this interface, right?
So will we build it as a test or a script, or how will we code that up? Or are you going to do it right from the console? Well, that's cool too.
Yeah, I prefer to do it from a test, right?
Okay, sounds good.
So we are basically gonna do the same as we do here. So, for example, token. Yeah, we're just gonna say get contract ERC20, right? And give it the ABI and give it the address, right?
Basically, you're saying here's the interface. So by saying it's IERC20, you're saying that this is this other contract that we've already compiled and you have all the artifacts for it. So grab those local artifacts and point it basically at this address.
Yeah.
Cool.
So let's just first get the
we're writing our first Hardhat test here, right?
Yeah.
Cool.
And we need the address of die. I also have that around
6 something 6B175. I see it over on the right.
Yeah. So right there.
Yeah.
Cool. So let's do console.log total supply. Let's say.
Cool.
Right. Okay, that should work. Let's just try it. So let's see what's failing.
Yeah, what's the name of the test? What's this file called over here on the left? Is it just T?
Yeah, sample test, but it should like,
yeah.
I didn't specify the, like, what test is.
I got it. So in NPM, where you did the init, you need to tell it what an NPM test. Yep, I got it.
Yeah, that's it. And I guess we can tell it the default network to be HartHat.
HartHat, yeah, which it seems like it's already using, but it's good to be explicit about it here in the config.
Correct, you're right. Okay, so that should work now. Okay, it's not reader, it's die, but yeah.
but we know, yeah, cool. There we go.
And it's telling us this
a great
weird
big number back. Awesome.
Yeah. So let's make it a little bit cleaner. Let's say supply equals that, right? And then we can do
probably format ether.
Yeah. And then supply, right?
Cool. And just for anybody watching at home, that was in a big number. Basically, JavaScript is bad at tracking giant numbers. So there's a big number library, and Ethers has basically you do parse ether to go to that big number 2 way, and then you go format ether to kind of come back and take a big number and display it. And there it is, a huge number.
Right. So that's almost a billion.
73. Yeah, 763 million die has been minted. Is that right?
Yeah.
Cool.
Yeah. So now what we want to do is
let's pawn somebody.
First, let's look how much we have, right?
Okay. Okay.
So
the balance of F3.
Yeah. By default, when HartHat spins the local node, right, with the fork and everything, it creates a few accounts that you immediately have available here. So we need to retrieve those, right? I think I have, you can do.
And you could just do like MPX accounts.
Yeah.
Oh, you could do MPX HardHat accounts, and it will list them too, right? If you were from the command line.
Yeah, because you can like build your own tasks.
There we go. And then we're gonna.
That's the demo one.
Here comes F3. Grab that first guy. So he basically has this F3 account has a crap load of gas, a crap load of ETH, but no die yet, right?
Yeah. So let's do balance. So instead of total supply, let's do balance off, and let's call, I don't know, this guy. Let's call it me, right?
Mm-hmm.
And we are going to grab this one. And it should have a lot of ether, but no die, right?
Yep.
So let's see.
This should be a 0. No, balance of will be, die will be 0. Yep. It should. I'm going to change that name.
Okay, so we
Cool.
have
Zero.
no die, right?
Yep.
But then we can go here to I looked this up on Etherscan. Someone who has a lot of die or some contract.
Basically a random account. Yeah. Or contract. Yep.
Yeah.
Got it.
Let's call it whale.
This is great.
Right. So let's see what the balance of whale is. Right. And it should have quite a bit.
It must take time. There's kind of a delay there in between. It must have to. Does it refork mainnet? Like it should just go right out and come back. But taking 5 seconds, it seems like that's a long time that it's taking to read.
What you can do is actually.
I mean, it's no big deal. Just wondering what's going on there.
And stick to a block. So the next time you query you make the query, it's going to cache the block, right? And if it already made that query, it's gonna be instant. So let me just see if that actually.
So it's reforking mainnet with each command. Is that what's going on? We're getting the latest block, and that takes it there's some overhead there of getting that. Oh, you're looking for an archive node. So it needs an archive node to get the block, and your Infura account doesn't have an archive node. You'd need to run a local archive node to pin it to a block.
Yeah, but we can also like get a later block. Like what's the latest? 433349, right?
Oh, do we have within like 256 blocks or something like that? And you're specifying a block that's before the 250. Cool, neat.
Yeah, and it's like we can't get that far in the past, but this is.
I tried running an archive node myself. It didn't work out. It used all my home bandwidth, and I had to shut it off.
Yeah, I wouldn't be able to even start doing it over here.
Right.
Okay, so if I do it again, it
should be quick now.
Maybe it's not. It's not fast because it won't me like, hey, we need more confirmations, but like,
I mean,
let me show you in my other project here, right? If I do that, if we use that block, like I do it a lot for development. Just fix a block number in a fork. And then develop, then remove that, and I know I'm forking the latest mainnet, right? Because at the moment this runs, you're on another chain. You're not on mainnet, obviously. So the first time, let's let it run once. The first time it's going to be slow.
Well, at this point, it should be cached, right? You could probably Control C and go. No.
Yeah, maybe on the other project. Oh yeah, it could be, but I'll just let it run.
Yeah.
Well, let's see. Let's try your theory. Okay. If I do it again, it's going to go to the same block, which it already interacted with. Yeah, so that part did it super fast.
Yep.
So if you're developing, you'd want to stick to a block and make sure things work in whatever time. Like you don't care.
You can kind of iterate on. I'll check these things, make sure that's right, add a few more things, and it's just going to be cached. But what we're doing right now takes a little extra because there's some overhead of reforking mainnet and requerying things.
And then you comment this out, and
it's so cool. We're forking mainnet, and we're taking over some account, and we're doing all this stuff locally and testing things out. This is super cool. Okay, so now our whale has almost $1 million of DAI. Right?
Yeah, that's a lot. So we're
gonna borrow some of that.
We want to take it, right?
Yeah.
So you need to do that. You need to call like a function in HartHat. I believe I have a utility for that somewhere around here. Yeah, RPC. Impersonate address here.
Interesting. Okay. That's an RPC request.
Yeah.
Impersonate address is an actual RPC. Interesting. I didn't know that. This is cool.
Yeah. So let's get a signer that represents the whale. Like right here, it's just the address, right?
Mm-hmm.
So now we're gonna do
probably create a wallet with ethers.
let's say whale signer. Okay.
Okay.
Yeah. It's this ethers object that can sign transactions, right? So we're gonna do impersonate address, and we're gonna say whale, right? So over here, we're gonna query our own balance, right? So, or just to make it more exciting,
I'm excited.
our very own balance there. And I think that's, oh yeah, we need to make the transfer, right?
Yep. So we'll check our balance and then maybe do a transfer and then check our balance again, maybe even, right?
Yeah.
We could do.
Yeah. Before, and then we're gonna do the transfer here. So what you do with ethers is they die.connect and you connect it to a signer, right? So connect it to the whale. That will allow you to execute a transaction on behalf of the whale. So
die in this case is a contract object, and we're taking the contract object and it was currently connected to the local provider without a signer, and we're going to point it at this whale signer, which is an impersonated EOA. This is cool. Got it. So now that our contract is connected as the whale signer, whenever we make a transaction on it, it'll be the whale signer making the transaction.
Yeah.
And we're going to transfer to me. Got it. Sorry, go ahead.
It's a bit of a fashion to leave something to the victim, right? So
like give him half back. Just take a haircut. That's nice.
Yeah. Okay. So we're gonna only take 500K, right?
Okay.
And then we can do check our balance again, right? Let's see if that works. It doesn't. Good. Invalid argument.
Format. Maybe we need to format ether. Yeah, on those balances.
Yeah. Yep. I put the console. This should be outside.
Oh yeah, I see it now. Yep.
Come on, man! I was just.
I should have seen that. I should have caught it. I should have caught it.
Okay. And same here, I guess. And awesome. This is after, right?
Yep.
What's the constant? Oh yeah, die is going to be variable because we are. This is kind of weird.
Must be that connect. Oh, yeah, do you need to do die.die connect? You may just do die connect.
Yeah,
or maybe it returns as connected signer. I don't know. Yeah, it's going to work though. There we go. Yeah, so our balance before and our balance after. So if this was some kind of actual flash loan or something that you had set up, some kind of transaction or series of transactions you've crafted, we tested it on our own node, but it's using Mainnet to make sure it works. So then what we could do is basically like point that satellite, instead of doing a Mainnet fork, we could actually point it at Mainnet and run it. And in this case, we're impersonating an account, and that wouldn't work once we tried to run it on Mainnet. But if these were all like valid Mainnet transactions and we weren't impersonating anyone, you just change your RPC to Mainnet and hit go, and that whole thing like actually works on Mainnet and runs.
Yeah, it's incredibly easy. Like I remember by the start of the year, this was possible, but it was hard to do with Ganache. It was kind of unstable and harder to set up, right? So I know in 2019, it was more like, okay, I want to try something out. I'm going to get the contracts and deploy, like spin up a chain, deploy their system locally and interact with it. But that's crazy. Like you need to know how to deploy the system, right? And now with forking tools becoming so powerful and easy to use, like in HartHat, for example, it's like all tests interact with the fork, right? And you have the real thing right here. And yeah, you could, like, I don't know, test your flash loan or in my case, the credit delegation, And if it works, you're pretty confident that it's gonna work when you do it.
And before mainnet forking, you basically had to deploy your own DAI kind of mock contract to your local setup. Like your local setup would need and the way DeFi and composability works is there's so many building blocks as part of the stack that if you want to iterate on one tiny thing at the end, you've got to put that whole stack together locally and then do that change. Where with mainnet forking, we can kind of just let's fork it right at this block. We have everything we need. Let's just make this one last transaction to make sure it works. This is so cool. Can we show off Alfred ETH? Can we show off your other tool, Alfred ETH, or Alfeth? How do you use it? Like, let's say we just need right now. I use it all the time. I do open Apple command and I type ETH and then gas, and it tells me the current gas price, which is 42. Oh yeah, of course, man. It's great stuff. I love Alfred. And
that's awesome because I never tested the installation process, so it means that if you installed it, that it works.
It was actually more complicated. When I saw your installation process, I was like, oh no, I'm gonna have to go buy this extra thing, and I kind of ignored all that and just installed it and tried to run it, and it ran. So it was good.
Okay, awesome. All right, that's good news. So yeah, the way I use it is you have these commands. For example, you can check the gas. Like I'm trying to put the things I do all the time.
Yes, exactly.
Of using other things. So if anyone wants to tell me what you do all the time and you hate to do it anywhere, I can put it here. And this is
one thing was block number, right? It'd be cool if somehow this, like if you could do ETH block number and it looks at just localhost 8545 and tells you the block number. Like we needed to know that just now to know what block number we were on. That would be a perfect little thing you could add to this. What does it talk to in terms of endpoints? Does it talk to Infura, or where is it? Like when it does that ENS query, it's got to go to a mainnet provider and get that ENS information back, right?
I think it depends on the command. Like this one is using Etherscan, so it's not just a provider, right? This one's pretty cool because you can give it a transaction hash, or you can give it a contract and a call data, and it's gonna parse it for you. Like it's gonna go to Etherscan and grab the AVI and tell you what happened. So like let's try it with one. This is one I use quite often. So let's suppose that, I don't know, I'm going to
just pick some random transaction here. Very cool. Okay.
Farm. Yeah, I'm going to farm something, which in reality I don't do too much. I was burned
to add some
by the
color
Deafy
there.
Summer.
To add some color there, this farming process requires like being in an intricate position where you swap something for something, you lock something else, you get a new token, you take that new token and you lock it up somewhere else. Like you have to kind of like roll up a position and roll in and out of a position. So what we'll see here is there's a lot of things going on. I mean, this is just a random transaction you found, but at least there's like 3 things here, and there's going to be some call data, and that's what we want to figure out. That's what we want to parse here.
It's not going to give you like the history, but you know, if you go to this new farm and you click a button, then Metamask will just say, okay, cool. Do you want to sign this transaction? And you see call data, and you have no idea what you're signing. It could be taking all your DAI, as far as you know, right? So the idea was to have a quick way of like asking, what did I just sign, or what will I sign, right? So for example, let's look at this. I just copied the hash. So you can, it's a bit slow, I'm not sure why, but it's basically retrieving the information from Etherscan. So it's calling Uniswap. That's the address.
And if you wanted to like copy the to address, you could hit Open Apple or Command 6 right now or something like that. That's so handy. So not only do you get like introspection to see what's going on, but you have access to all these little pieces and can copy paste them as you need. That's super handy.
That's a pretty cool address, ACE.
It is
16.
ACE.
But yeah, it's supposed to be copied. Yeah.
Yep.
But that's if the transaction happened. So let's suppose that we didn't have that. Like it's asking for us to sign it. So the first thing you would need is the address, right? And it needs the other parameters. So what I do is just close it, and then you would get this from Metamask, right?
Just
The
get
call
the
data.
raw call data.
So
Yep.
hey, yeah. Hey, then I go up and I paste
I
the
didn't know how
other
to do
part in.
that. You hit up, the up arrow does that?
Yeah. Well, there's something weird going on. Let me see. Maybe I pasted something wrong. Yeah, I didn't separate them. Shit.
Yeah,
Yeah,
you want to go, I
let's
think
do it
that
again.
direction. No, that's the right direction. Just go. Oh, you got it. You got it.
Yeah, yeah. So I think I should have the first one. Wait, yeah, I forgot a space. Yeah. Then it should give me the same information, right? But in theory, if I'm getting this from MetaMask, it didn't happen yet. And I'm like, okay, it's, if it gives you anything, at least the contract is verified.
Right. You know
Right.
that it's gone out, it's gotten the addresses ABI, it's parsed through this
Yeah.
stuff. Like this is a valid contract out there, and this call data matches
Yeah,
that.
yeah.
You're not going to hit like some fallback
Yeah.
function or something like that. Very cool.
Yeah, yeah. Yeah, so
Awesome.
so that's something I use a lot. Also, if you, I don't know, if you are on a DAO or something and someone asks you to sign a transaction,
Yep.
you can,
Call data is just messy. Yep.
Yeah, you can just come in and check. Like I can't believe, I don't know, a lot of tools don't do this yet. I don't understand.
Right. There really isn't a great React component for parsing call data yet. I mean, there's probably a couple out there, but they may not be open source, or I don't know about them. But that's something that we would be awesome, right? Something that you can throw call data into a React component, and it's like, oh, here's the function you're calling, here's the arguments, here's the argument types, right? Like that gives you that pretty Etherscan view, but within your own app. That's definitely something I want to see get built in the next couple of months. Something that if it isn't out there, I want to see it built. How about just like close this out with just like what other tools do you use on a day-to-day basis? Like where do you go to find tools? Where do you go to learn stuff? Like what's your just kind of open-ended hints to other developers?
Well, Google.
Absolutely.
Well, yeah, I like to do things vanilla, so I don't have much of a stack to show off, right? And I'm also a back-end developer lately, so I'm not up to date with a lot of libraries, you know. And in my case, it's a bunch. It's like knowing, I don't know, how Ethereum works. Let me show you where I spend most of my time.
I'd love to. Yeah. Solidity, read the docs, right? Or Solidity by example, one of the two. I love those. Yeah, oh man.
Here,
yes, it's such a good resource. Yep.
Yep. And then
this is perfect. This is great.
HartHat.
Yep.
That's where I spend my time. Like it's pretty low level, so I'm here all the time. Then lately I'm using like vanilla JavaScript, so I don't know, just do JS and whatever I need to know.
Where are you with JavaScript versus TypeScript? How do you feel about TypeScript?
Well, I like it. I like TypeScript, but I recognize that just for quick prototyping, JavaScript is just awesome. Like the way we just spun up HartHat and wrote that freely is amazing. But then if I had to like go into a big project tomorrow and I heard that they use TypeScript, I'll be happier because I will be able to read the code much faster. But that's pretty much it.
That's great. That's wonderful. Yeah. So just to close out, just to kind of recap, basically what we could have done and what we kind of did is Aave deployed a new contract with new features, and it wasn't in their front end yet, but we don't need front ends because this is a decentralized world. We're interacting with smart contracts, right? So basically we installed HartHat. We created a vanilla project. We kind of brought in the token ABI to that contract. We pointed that contract at an Infura node and told it to fork from the mainnet Infura node. And then we went and grabbed some DAI from a whale and did this, impersonate account call, and basically took the DAI from the whale, and then we can kind of do whatever we want with that DAI on mainnet. And it lets us test if this thing is actually going to work. And it's kind of like pushing this is state of the art. Aave doesn't even have a front end for this yet. But what's so cool about all of this is then now you can push that repo back up and you can tweet about it. And anyone else in the ecosystem can come pull that repo down. They can look through it, make sure it's pointed at the right place, and they can run it with their own stuff. And this whole composability just builds on top of stuff, right? Like I could build a front end for that, and we could have credit delegation on Aave without Aave's front end at all. And that's how the ecosystem works. In the next hour, yes. It's so awesome.
It's going to be
so
ugly,
exciting.
but it's going to work.
It would work. Yep.
Yeah.
Very cool.
Yeah.
Well, thank you very much.
That
this
project,
has been awesome. Yeah, let's go ahead, please.
Just a little more of like,
yes, please.
Like, technically, it's the same that we did here, but reading their documentation and just, okay, this is how you deposit. You make it work, and then you move to the next step until you just played out the whole flow. That's it.
Yep.
But yeah.
Awesome. And technically, you wouldn't even need their documentation, but it's very handy. You could technically go read the contract and find out like, oh, then there's this, and then there's this. That would take a lot longer. It's nice that they have documentation, but just a smart contract getting deployed is all we would need to then kind of start building this next layer on top of it. This has been wonderful. Thank you for showing your stack, man. This is, oh, go ahead. What's up?
No, I was, sorry, I was just, stuck on the conversation. I just wanted to say that this is like, you cannot sign transactions with your hardware wallet, for example, with this script, right? So I'm not actually using the script to interact with the contracts. I'm just using the script to simulate or understand how to interact with the contracts. But then the actual interaction would be through, I don't know, Etherscan or something. Or you could use one-click DAG, just give it the ABIs and then use Metamask. Yeah, I don't know enough about front end to like. Surely there's a way to hook up your ledger here, but I don't know how to do it. But just clarify that.
Yeah, so, okay, let's talk about that for a second. So basically you would run all these tests, you would figure out like, I need to make this call, then I need to make this call, then I need to make this call. You'd get it all working, you'd prove it that it's gonna work on mainnet. And then would you output some kind of call data? Like what would be your process of taking that and actually executing it? Like, would you basically manually go do this? You would go to Etherscan, go to the contract, find the function, paste it in and run it, and kind of run them one at a time? Yeah,
that's why I'm like, printing out with colors the addresses.
Got it.
Like, so I go to Etherscan to this address, and then I know what function to call, and I just put in the parameters with the help of Alfred. Like, okay,
awesome.
What's 10,000 Ether, right? And then it gives me the way, and then I paste that. Yeah. Okay, awesome. I'll let you finish now.
No, it's great. No, this is awesome. This is neat for me personally. Like today I learned a lot of things, but I think this will be awesome to share and show off to other developers, and just kind of like, it's so cool to see how other developers are really using things and how their stack works and the pains that they have. Like this thing that you're talking about where you do this intricate testing, and then you basically kind of go caveman on it for a little bit in Etherscan, and maybe that there's room right there. We can see how great HartHat is, but we kind of need something else over on that other side, or maybe something that plugs into HartHat that says, here's all your tests. And now there's like a nice UI, and you can connect your MetaMask or your ledger or whatever, and then just like hit those buttons, and it triggers the dialogue to come up, right? There's definitely like some stuff we can add to that, awesome. And neat rooms for improvement. Cool. Well, this has been really fun. Any closing thoughts from the Ethernaut?
No, not at all. Let's just build all this stuff.
Hell yeah. Hell yeah. All right. Happy Bowtie Friday, man. This has been great. Thank you for doing this.